Hello guys, my name is Balkrishna Srivastava and welcome to Code with BK. So in this video, we write a program to input the value of x and n and print the sum of the following series. And this question is in the list of suggested practical programs for CBSE Class 12, Class 11 Computer Science students. So before we begin, it is a request to please subscribe to my channel, because out of 100 viewers, only 2 to 3 are subscribed. More than 95% of my audience is not subscribed, and a subscription is very important. So please do subscribe to my channel. So I will be solving this and the other problems in this list as well. So as and when they are solved, the links for those videos will be found in the description of this video. So you please make sure that you check the description of this video. And also I have solved all these questions in Hindi on my Code with BK Hindi channel. So if you are better comfortable with Hindi, you can take a look there. And also, if you could just spare 5 minutes, take a look at my Code with BK Hindi channel. Please let me know your reviews about it. So we have to find the sum of all these series. So I've taken 4 separate functions, one for each series. Okay, let's start with the first one. So all you have to do is loop from 1 to n, and in each iteration find x to the power I. Okay, where I is the loop variable. So x to the power I for I equal to 0, 1, 2, 3, 4 till n. You sum it all together and then add 1 to it. Make sure you don't forget to add 1. So if I go back to my code for my first series, I'm going to say sum is going to be 0. Okay, then add terms of x. Okay, then add 1, because apart from the terms of x you also have to add 1. So I say sum plus equal to 1 and then return. So return sum. Okay, so adding terms of x, we have to iterate from 1 to n. So for I in range 1 including n, so n plus 1, I find the term, okay, which is going to be x to the power I. So x to the power I using exponentiation operator, and then add it to the sum plus equal to term. Okay, so this will add terms of x, this will add 1, this will return the sum, and that's all we need. Okay, so we have to take input x and n. So I'm going to write x is float of input of enter the value of x. Okay, and similarly n is going to be, number of terms is going to be an integer, because x can be any real value. Okay, so it has to be a floating point value. Input enter the number of terms. Okay, and you can say number of terms n. Okay, so we can say sum1 is series 1, pass the value of x and n and print an output. You can use a formatted string. Sum of series 1 for x equal to x, okay, and n equal to n is sum1. Okay, let me just bring series 1 here so that we can have all the code that we have written together. Okay, right, so we have to run this. I'm gonna bring myself here. Okay, so python 3, I'll say series 1.py. so 1 and n equal to 4. So for x equal to 1 and n equal to 4, these all will be 1s. So 1 plus 1 plus 1 plus 1, 4 plus 1, 5. So we should get 5. Okay, let me run this again. X is say 2 and number of terms are 4. Okay, so number of terms are 1, 2, 3, 4. So n is 4, so same, these 4 terms will be added. So 1 plus 2, 3 plus 4, 7 plus 8, 15 plus 16, 31, right? 31, right? And this is your answer for a series 1. Okay, you can take any floating point value as well, say 2.23, and n is say 5 terms. Okay, comes out to be this. Okay, so this is your series 1. Let's move on to series 2. Okay, so in this case you have to subtract terms of x which have odd powers. So minus x cube, so minus x5, minus x7 till whatever the value of n is, right? So when you are summing the terms of x, you subtract the ones which have odd power. So going back to the code, my series 2 sum also remains very similar. Okay, it's just that add terms with even power. Okay, subtract with odd power. Okay, so how to check if the power is even or not? Power will be even if it is a multiple of 2, right? So if I % 2 equal to 0, it means I is even, it means the power is even. In that case, we add to the sum. Okay, else with the case where the power is odd, we subtract from the sum. Okay, so sum minus equal to term. Okay, and then we finally add 1 because that is to be done separately. Okay, so for any value of n where I is the value in each iteration, x to power 1 when I equal to 1 is subtracted, x to power 3 when I equal to 3 is subtracted. Similarly, all even powers I equal to 2, I equal to 4 are added. Okay, all right, so let me just bring this here to the code. Okay, all right, okay, so again running this now, I'm gonna bring myself here again, so clear. Okay, we are, we did not write testing for series 2, series 2, and sum 2 and sum 2. I will comment this out for now. Okay, and stop and run again. Okay, render the value of x 1 and 4. So for x equal to 1, n equal to 4, these 4 terms will be added to the sum. So minus and plus for x equal to 1 is going to cancel these 2 terms and then these 2 terms, so we are only left with 1. Okay, running with x equal to 2 and equal to 4. Okay, equal to 4, sorry. So 1 minus 2 is minus 1, plus 4 is 3, minus 8 is minus 5, plus 16 is 11. Yeah, so that's what you get. Okay, so this is your code for your second series. Okay, for the third series we don't need this addition of 1. Okay, but the powers are calculated in the same way. Copying and pasting this for the third series, this is not needed now. Okay, you calculate the term in the same way, x to power I. Okay, so I takes values from 1 till n. Okay, 1 till n, and each term is x to power I by I. Okay, in this case x to power 1 by 1, x to power 2 by 2. So if I is the value in each iteration, you have to calculate x to power I by I. So you can say x to power I divided by I, and then add it to the term. Okay, no separate addition of 1. And let me just write, okay, the code to test this. So I'll say sum 3, series 3, and sum 3. Okay, comment this out. So testing series 3 now. So the enter value of x, I'll say 1 and then 4. Okay, so we have x plus x square by 2 plus x by 3 plus x4 by 4. Okay, so we are using 4 terms, right? N equal to 4, so that's we are using 4 terms, and we have x equal to 1. Okay, so 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 is 1 plus 0 0.5 plus 0 0.33 plus 0 0.25. So 1.5 plus 0 0.5333, 58333, right? 58. Okay, so this is going to be 2.083333 something, which is what we are getting here. Okay, let me run this again for n equal to x equal to 2, n equal to 4. Okay, so this is going to be 2 plus 4 by 2 plus 2 cube by 3 plus 2 4 by 4. So 2 plus 2 plus 8 by 3 plus 16 by 4 is 4. So 4 plus 4 plus 3, 8 by 3 is 2.6666, which is 8 plus 2.6666 is equal to 10.6666, which is what we are getting here. Okay, so your third series is fine as well. Okay, moving on to the final series. In this case we have to calculate the factorials. Okay, the denominator are the factorials. So for each iteration I, the term is x to power I by I factorial. Okay, so if you copy this into our series 4, okay, and let me just bring it closer to our testing code. Okay, so the term is x to power I by I factorial, so this has to be replaced by a factorial of I. Okay, for that we'll have to write a separate function. So I'll write a helper function def factorial, and I pass the value n, so this returns n factorial, okay, and n factorial is equal to 1 into 2 into 3 into 4 till n minus 2 into n minus 1 into n. Okay, so given an integer n, and factorial is basically the product of all integers from 1 to n. Okay, So you have to find the product. So I start with the product of 1 because 1 into any product is the same. Okay, so we start with 1, we get the right product. So for I in range, you have to start with 1 including n, 1 including n. Okay, and you have to say product into equal to I. Okay, and return product. Okay, this will give me the factorial, and in this function replace I by factorial of I. Okay, so the factorials will be, so we will have 1 factorial is 1, 2 factorial is 2, 3 factorial is, so this is basically 1 into 2 stays 2. Okay, 3 factorial is going to be 1 into 2 into 3, it is going to be 6. Okay, 4 factorial is going to be 1 into 2 into 3 into 4, it will be 24. Okay, now we need to test series 4, so copy, paste. Okay, sum 4 series 4 series 4 sum 4. Okay, all right, clear. Bring myself here. Okay, Python 3. So x is say 1 and n is 4. Okay, for 1 and 4, okay, you should be getting 1 and 4 we have x plus x square by 2 factorial plus x cube by 3 factorial plus x4 by 4 factorial. Going to be 1 plus 1 by 2 plus 1 by 6 plus 1 by 24. So 1 plus 0 0.5 plus 16, 6 is 96, right? 0 0.16 something, right? Plus 24, 4 ja 96, right? 0 0.04 something. Okay, so 1.5 plus 0 0.16 something plus 0 0.04. Okay, 1.70 something something, and let's see what the answer is. 1.70 something something, which is what you want. Okay, and this is your series 4, and we have, this is your code. Okay, so this basically is to test if you can run loops correctly. Okay, series 1, series 2, series 3, series 4. Okay, also gives you an introduction on what is, how to calculate a factorial. You can use loops, you can also use a recursive method to find factorials of an integer. If you want that code, you can let me know in the comments, or if the code is already added, you can find the link of the video in the description of this video. Okay, this was the solution to this problem. Okay, and I will be solving other questions as well. As and when they are solved, the links for those videos will be in the description of this video. And again, I have solved these questions, all these questions already on my Code with BK Hindi channel. If you are comfortable with Hindi, you can check out all those videos on my Code with BK Hindi channel. Okay, so this was the solution, this was the code, and I hope this was helpful. So if there is any doubt, there is a part you don't understand, please let me know in the comments. I always try to answer all the comments, and you can also let me know in the comments if there is a question you want to solve or if the concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.